In this video, I'm going to explain the difference between average acceleration and instantaneous acceleration. First of all, acceleration is defined as the rate of change of velocity with time. So you could say acceleration takes it one step further. We define velocity as the change in displacement over time. Acceleration is now the change in velocity over time. Again, like with velocity, we have two different kinds of acceleration. There's average acceleration and instantaneous acceleration. When we talk about average acceleration, we're talking about obtaining the slope of a curve. So let's say this is our curve, and we have velocity here and time here. We are obtaining one point in here, one point in here, and then we take the slope of those 2 points. This gives it a beginning and an end, and that is what represents average acceleration. So we'll have a beginning as well as an end. Well, out of this, we can obtain the formula. We said it's the slope, so the average acceleration, I'm going to call it AX average. It's going to be the slope. So that's going to be y2 minus y1 over x2 minus x1. Y, in this case, y is our velocity. So it will be v2 minus v1 over t2 minus t1. And you can just represent it as the change in velocity over the change in time. And that is average acceleration. When it comes to instantaneous acceleration, we will be thinking about an infinitely long curve. So we want that rate of change of velocity at any point of that curve. There is no beginning and there is no end. We want it at every point or any point. And the way instantaneous acceleration is found, like with velocity, is by obtaining a derivative. So we say it's any point. And because the acceleration is the rate of change of velocity over time, we will obtain the derivative of velocity over time. So our AX is going to be the derivative of velocity over time, or with respect to time. And we can get this further because we know that the instantaneous velocity is the derivative of displacement over time. So we can say that the instantaneous acceleration is the second derivative of displacement over time. With respect to time squared. What this means is, if we are giving a value of displacement, we can obtain its derivative twice to obtain the acceleration. If we're given a value of velocity, we can obtain its derivative once to obtain the acceleration. And those are the difference between average and instantaneous acceleration. Thank you for watching this video. I hope you liked it and found it useful. And if you did, please be sure to give it a like and subscribe to see more videos like this one.